From the massive studios in Raleigh, North Carolina, this is the Cloudcast with Aaron Delp and Brian Gracely, presented by A Cloud Guru, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are. Welcome back to the Cloudcast. We are coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. Big day on the show, Aaron. Good to have you on.
Yeah, absolutely. And so, Brian, are you recovered from Krispy Kreme? We kind of have to do a quick recap.
Well, we will. But before we get to that, man, today's a big day. Today's your birthday. Happy birthday.
I didn't think we were going to actually cover that. Yeah, no, absolutely. Today is my birthday.
Another year of 29.
Depending on when you listen to this. Yeah, so exactly. 29 again. No, man, I feel old today.
Welcome to the club. Welcome to the club. So,
well, in a semi-related, right? So if I go back to the Krispy Kreme challenge, raising the money for the Children's Hospital, I was actually thinking about this the other day. This year I ran the race cold, and I swear I'm still sore from running 5 miles with no training whatsoever. And I did it last year, and I was like, is this a trend as I'm kind of moving into my old age here? And then when we did start this podcast, like thinking back, it was either the first year we did this or the second year we did this was back when I was running half marathons and 10-mile races, and I was in really good shape, and I was, really happy with my physical fitness. These days, not so much.
Yeah. There you go, man. Something to aim for, something to work towards.
But I can say this. So, those that have been listening a couple of shows ago, we kind of did the rock report. I can say for my birthday, I did get Journey and Def Leppard tickets. So there's an upside to all of this. Yeah,
good,
absolutely.
Good. Well, listen, why don't we do? We got a little bit of house cleaning. Yeah, a little bit of housekeeping, and then we'll get to our guest.
What was the grand total? It was close to $4,000, correct?
Yeah, I think we finished at $3,855, so just a hair under $4,000. So thank you to everybody who donated. Another Cloudcast community was first in community again this year, so thank you very much. 6 years in a row. We've said it over and over again. Can't thank everybody enough for being so generous. So thank you for that.
Yeah, absolutely. And I think the grand total for the last couple of years is $27,000 kind of lifetime right now, and so we're really looking forward to kind of breaking the 30K mark next year as well. Can't wait.
That's right. The other thing we've got some new things for the audience.
Yeah, absolutely. So our sponsor for the show, A Cloud Guru, was really great. They reached out to us recently and said, hey, we've got some new offerings we'd love for y'all to just kind of tell everyone about. And so I don't know that we even talked about it up until now, but it actually has been out for a little bit. A Cloud Guru, up until recently, was purchase the courses and kind of pay as you go, and they've developed a membership now as well. And there's a free trial for the membership, and then there's a monthly payment or a yearly payment. And if you were an existing customer and bought some of those courses are still there, but the membership gets you really great benefits. It's a bit of an all-you-can-eat model, all the training you could ever want for one monthly cost. And I just think we helped them out with a lot of this. We gave some early feedback on it, and it's just a fantastic program. Super excited about it.
Yeah, so definitely go check it out if you're interested. If you're trying to learn some new stuff, all the details are in the show notes, as they always are. They'll be updating stuff as we go along, kind of quarterly as well. So always going to be a little bit of free stuff, always going to be some discounted stuff, but continue to love working with those guys. Listen, man, we always say that one of our favorite topics, one of our favorite types of guests, types of topics, is to get a chance to talk to the venture community. So today, very excited to have kind of a longtime friend that we've just never had on the show before. So excited to have Lenny Pruss. Lenny, who comes to us from Amplify Partners, partner at Amplify Partners. Lenny, welcome to the show. Glad to have you on, and we've finally gotten over all our little technical hurdles. So great to have you on the show.
That's right, guys. I feel like it's a long time coming. So excited to be here, and Aaron, happy birthday.
Oh, thank you. No, and thanks for being on the show. Yeah, like Brian said, it was one of those. Your name popped up for this thing. I'm like, we hadn't talked to Lenny yet, really? Oh my.
Yeah.
Hopefully, it won't disappoint.
No. So listen, we've known you for a while. We've had a lot of conversations about where's the future going and what's this technology. But for anybody who has never met you, doesn't know you, give us a little bit of your background. Both pre-venture capital and then how you got into the venture capital game.
Yeah. So to go pre-venture capital, I gotta take you way back, because I've been doing this most of my adult life. I was actually born in the former Soviet Union, moved to the Bay Area with my parents at the age of 3. Both my parents were trained engineers, industrial industrial and mechanical. And of course, as a rite of passage, I went to UC Berkeley and enrolled as a CS major. And that's kind of where the story takes a turn. It took me about a semester and a half to realize that, man, I'm just not cut out for this. I stink as an engineer, and going down that path would be a career limiting move, as they say. But the benefit of being in the CS program is I met some brilliant people, and it exposed me to the possibilities in the world of technology, and more specifically the startup world. And so from a pretty early age, I knew I wanted to be in technology, just probably not the right person to be building it. And I'd heard about this thing called venture. It seemed to be a pretty interesting path. It really catered to my ADD and would give me an opportunity to work with folks much more talented than I. And so close to right after college, I was able to land a gig with the folks at RRE Ventures out in New York. And they were looking for an associate to join and run around New York and turf up some really cool opportunities. Problem was I landed in New York right in January of 2010. And at that time, the startup scene was really abuzz with things like Foursquare and Tumblr and social and mobile. And for whatever reason, I couldn't grok those apps, those technologies. They didn't really resonate with me. But as it so happened, this thing called the cloud was really emerging, and there were some other interesting trends around DevOps and cloud and big data analytics. And so that gave me an opportunity to kind of jump in and jump down the rabbit hole and see what all those things were about. And as it so happened, there just weren't a lot of folks in New York focusing on those industries. And one of the first companies I met and actually had the privilege of investing in was a company that has been on your guys' show a few times called Datadog.
Yeah, love those guys.
And so you talk about beginner's luck. That's kind of case in point right there. And so venture is this interesting career where it's sort of self-fulfilling in some ways, where you invest in a company, you build a network, you become associated with that company, you build a bigger network, and that leads to new interesting opportunities. And so I was able to emerge as one of a few guys that was focusing on these enterprise B2B markets in New York. The next problem that happened was I found myself spending more than 50% of my time on a plane traveling out to the West Coast. And being that I was from the West Coast, I decided to move back and was fortunate enough to join the folks at Redpoint in the early stage enterprise team, which is, I think, where we first met and our paths crossed, particularly around all the stuff that was happening in the container world and with the CNCF. And then more recently, jumping ahead, just about a year ago, I joined Amplify. And the story there is I'd actually known Sunil Dhaliwal, who founded Amplify, on the board of Datadog. He made that investment when he was still at a fund called Battery Ventures. We kept in close touch, and I was sort of blown away by the work and the firm that he was building with Mike Dauber and David Byer. And, I think if there was a firm that encapsulated my industry focus, my approach with entrepreneurs, and how I saw the role of VC, it was really those guys. So about a year ago, I made the leap. And so now I'm a partner with Amplify, and at the simplest level, we're an early stage venture fund. We back highly technical teams solving complex problems across distributed systems and infrastructure, developer tools, the emergent ML AI stack, and applied AI and security. So that's sort of the who, but I think the why is relevant here. So if you guys don't mind, would love to touch on why Amplify exists, because I think it's important. So Amplify was really founded based on two realizations that Sunil had circa 2011 and 12, and I think this will resonate with you guys. And the first observation was that the background of entrepreneurs who were attacking traditional enterprise B2B markets had changed pretty dramatically starting around that time. Whereas before we saw folks from product-centric organizations like Sun and Oracle and Cisco that had been really building technology for end users, at that time we started to see people from Google and Twitter and Facebook, or even directly from academia. And those folks were incredibly talented engineers, but they really didn't know what it meant to build technology that was going to be consumed by the outside world. And often those folks didn't even know what a sales guy looked like, how to hire a team. So while this class of founder was incredibly technically talented, they had a lot less fluency around company building. The second observation was really that starting around 2010-11, the venture industry started to take the shape of a barbell. And what I mean by that is there was an explosion of seed funds who would put in, write small checks for small ownership in a lot of different opportunities and take really kind of an index approach to investing in startups. And traditional early stage funds that were, call it 200, 300 million, ballooned up and raised 500 million, if not $1 billion funds. And simple venture economics dictate that those funds simply needed to put more capital to work. And in those funds, partner time generally follows money. And so you had this phenomenon where you had this class of really technical founders who needed more help than ever ever. And yet the venture ecosystem was really ill-suited to help. And so Amplify was really started to fill that gap. And so all we do is we work with really technical teams, working across 4 or 5 of our key domains. And we do everything in our power to make those entrepreneurs as successful as they can be from month 0 to month, say, 36.
Interesting. Yeah, I know one of the things we had talked about, in our year-end wrap-up show was we at least had some sense that, the way early venture or sort of second round, third round venture was happening had been changing. And it's good to kind of get some insight into, what changes early investing, late investing, and so forth. So I appreciate the kind of the perspective on what Amplify does that's different from other investors in this space. Because it's definitely something that I don't think we really understood, but I think it was something that we were seeing from talking to certain startups or talking to companies who, we had seen get an A round, but then were, telling us they were struggling to find a B or a C or something. So appreciate the kind of the background and the insight.
Absolutely.
One of the things that we noticed recently, you wrote a piece recently called Infrastructure 3.0, with a focus on AI and ML, and it's in the the links in the show notes. But we're curious. So you sort of laid out a premise of how the world's been evolving, both from an application perspective, an infrastructure perspective, where they had kind of been in lockstep in terms of innovation, and you throw out this premise that lockstep is really changing. Can you give us a sense of how we got here, and then kind of set up the premise of where you think this stuff's going or how it's evolving?
Yeah, so I think it's really important to note that a lot of these trends that take off, they don't happen in a vacuum. And I'm sure you guys have heard the saying, history doesn't repeat itself, but it often rhymes. Well, I think if you follow the history of technology and you chart the course of how the tech stack has evolved, I think it more than rhymes. I think it comes really close to repeating itself. And so, you could chart the trajectory or how the evolution really by paying attention to what's happening, at the interface layer, how we're consuming applications and technology at the actual application layer, and then the infrastructure layer. And so if you bear with me, happy to walk through at least my rudimentary theory of where we've come from. And I think it sets out a pretty interesting path where you could start to see what the next cycle might look like and perhaps even where opportunities lie. So, initially going way back to this, 60s, 70s, and 80s, we had these mainframes. They were vertically integrated giant computers. They were, generally interacted with or through terminals, and they were really good for kind of really big calculations and some rudimentary back office applications. And at most, these systems really affected or were used by thousands or tens of thousands of people. And then you had the OS was kind of disentangled from the mainframe, and then came the PC revolution. Killer app really became business productivity. The spreadsheets and Word docs and PowerPoints that we all still use today, and those really empowered millions of consumers and millions of business users, and that really gave birth to the client server architecture that dominated the enterprise really until the mid-aughts. And if we think about those technologies, principally, you have the standard PC operating system Windows, the x86 instruction set from Intel, LAN switching from Cisco, the Oracle relational database. Like the commercial internet really grew up on these technologies, and the web scale giants that we think of today, right? In fact, I think they still use a bunch of these technologies, right? I think Salesforce is still the largest customer of Oracle or something like that. So as the commercial internet grew, right, we were able to, and really expanded because of the advent of things like the iPhone, the mobile interface, and the dominant application really was a social application. The internet ballooned, the requirements of applications really morphed. And so that necessitated a rethink of infrastructure. And so that really precipitated the cloud infrastructure that we know and love today. And so, that gave us things like Linux and Hadoop, Arc and Mongo, and more recently things like Docker and Kubernetes and Cockroach DB and so on and so on. But if you think about what these technologies do really, really well, they're really, really good at distributing applications to billions of users and then storing information about those users or about the interactions of those users really efficiently. And right, so what they're not necessarily good at is high performance analytics or storing information about those users and their interactions. And so what the cloud really gave us then was this kind of elastic source of compute and storage. And then call it in 2012 with some real innovations in algorithms, principally around deep learning, we were able to sort of walk into or saunter into the age of machine learning that's kind of in front of us today. And so that's sort of where we are, right? We're on the downward slope of the cloud curve, but we're rapidly entering this new world of what what we can call intelligent pervasive compute. And in this world, the new interfaces aren't just laptops or mobile devices. They're all sorts of connected devices. They're numbering in the tens of billions, and all these devices are quote unquote smart.
Right.
And so to me, right, like this shift is perhaps more radical than anyone that we've ever seen, because not only are we dealing with fundamentally new application architecture, but computation is going to be all around us. It's not going to be done on the client. It's not going to be done in the cloud. It's going to be everywhere. And what this practically means is that there's going to be an exponential growth in the capability, or there will have to be an exponential growth in the capabilities of infrastructure technologies, of processing, of the network, of storage, of data management, and so on. And so again, if we rethink back to previous cycles, we've had a new stack and a new reference architecture emerge every one of those cycles, and new winners emerged. And so I get a chuckle when I hear folks talk about how infrastructure is dead. And so, maybe cloud infrastructure has kind of come and gone, but I think the opportunities in front of us are as exciting as ever.
And I think we've sort of scratched the surface of that a little bit on some of our shows. I mean, obviously we've been, having these conversations where, we've had people come on that talk about, voice as a new interface, new experience, the expectation that people have regardless of, what computing device that you're interacting with, whether it's a, phone, a laptop, a kiosk, a voice thing in your car, wherever, like you expect computing to be everywhere. You also expect it to be sort of instantaneous in its response to you. And we've kind of loosely joked around with this idea that, you can't really define what things like AI and ML are anymore, because as soon as they become mainstream for what you expect, you no longer think of them as sort of this amazing thing, and you move on to it. So yeah, I would agree with you. I think we're beginning to see what the sort of AI and ML technologies can do. And then you start to say, well, okay, the infrastructure that they run on, wasn't really designed for, these kind of pipelines that were there, right? We've put them together, we kind of make them work, but, they've never really been optimized. So I think where you're going with this is, there is sort of a revolution coming in what this new infrastructure for these kind of everywhere, all the time applications are going to look like.
Yeah, no, look, that's exactly right. And we're sort of in that weird phase of that lockstep evolution where, just like Facebook was built on, traditional servers racked in their own, sort of, or in a colo running MySQL, we're similarly building, these really data intensive AI centric applications on what I think will be deemed legacy building blocks. And again, I'm not going to be so bold as to say that clouds won't exist, or old programming paradigms won't exist, right? Like mainframes are still $1 billion business for IBM, but I think there's just so much opportunity because we are in this kind of evolutionary state, and just at the outsets of understanding the implications of AI and what that means, not only for applications and broader society, but really what it means to build these new kinds of computing systems.
Right. And I think when things are sort of early like this, it's useful to have some common terminology, some frameworks that people won't be exactly laid out, but are, something they can go, okay, I've heard that before, I want to dig into it. You use kind of a set of terminology, you call it connectivity versus cognition. Can you give us a sense of just, what does it mean, those two things, in terms of, the difference between one generation and the next? Yeah,
sure. So I think kind of the seminal piece that inspired some of my thinking was actually written last fall, maybe in November, by Andrej Karpathy, who's Tesla's director of AI. And he wrote a blog post titled Software 2.0, where he really talked about this difference in how we traditionally built software and how that's going to change in the AI world. And so I could try to do it justice. Here we go. So, I mean, to me, the fundamental difference before AI was that the way we programmed computers or the way programs ran were largely based off of rules or heuristics that a person would code into them, right? Mm-hmm. So we would hand code a program to perform a very specific task. There would be some known input. We would have a very specific behavior in mind, and there would be some known output. And that works just fine for regular programming. And I think that's going to make a ton of sense for many applications. And frankly, I think this for a lion's share of programs, this will be far more efficient than leveraging AI. But with AI, right, the paradigm's sort of inverted, where instead of telling a computer explicitly what to do, we tell it to teach it to learn how to pick up patterns or understand context or make a decision. And so the canonical example here is, if we had to teach a computer how to identify a cat, if we did it the old way, we'd have to sort of go line by line, write thousands of rules to describe what a cat might look like, right? There's a whisker, it's typically this girth, it's this length. We have to think about pixel size. Then we have to think about edge cases. This is a house cat versus a tiger versus a lion. And handwriting a program like this could be thousands of lines of code and can take many engineering man-months. With AI, and particularly with deep learning, what we're doing is we're taking a training algorithm, typically a large neural network, and then we're feeding that network huge amounts of data until the program itself can develop a model. It can learn a model of what a cat does or doesn't look like. And then we can implement that model into a larger system, and that serves as the core business logic.
Right.
So, in this case, we've got algorithms and data that together that are responsible for writing this logic, and humans are really playing a supporting role, right? They're tuning the algorithms, and then they're creating the data pipelines that are feeding the algorithms, and then they're redeploying the model. And so over time, I suspect we'll start to see more software written like this.
Mm-hmm.
We've got a company in our portfolio that is working on a really exciting new area of research called code synthesis. These guys are taking plain text and they're spitting out code. The founders often joke that if they're successful, they'll have innovated their way out of a job.
Sure.
But yeah, this hits on a bunch of this hits on really the core premise of just how different this programming model really is.
Right. And I think you sort of highlight, right, it's a model that, and you've got some diagrams of it, so neither one of us are going to do it justice, kind of chalk through it. It's worth taking a look at the diagrams in the link. You do a good job of kind of laying out the pieces of this. There are a lot of pieces that go into collecting the data, getting it cleaned in certain ways, not having to clean it in other ways, modeling it, actually doing the computation is only one small piece of this. As you're thinking about this, give us some sense, right? So some of these things kind of happen today, right? I can do pipelining in AWS service or Google service or Microsoft service. We're seeing things like GPUs happen. People are kind of cognizant of that being, one of the building blocks. Give us a sense of, what are, as people are watching this evolve and a lot of times when there's big ideas thrown out there, they're like, okay, cool. I know that's going to take a long time. When do I think I'm going to start seeing some things? What are some of the next building blocks for people to look at to go, oh, okay, cool. We're moving into that next phase of things, right? Is it, Are you seeing things in your portfolio on the horizon, or is it just, the price point of a GPU, or what are some of those things for people to look for?
Yeah, so it's interesting. I think the first point in time where it dawned on me that this was something completely different and truly disruptive was the fact that about a couple of years ago we started seeing a resurgence in actual systems and semiconductor companies. And part of that's really related to the fact that, AI is kind of represents a wholly new architecture that is really computationally expensive and it's really data intensive. And so, if we talk about, traditional kind of general purpose compute architectures, they have, memory hierarchies that were really well suited for, kind of traditional computing as we think of it. Just they're really good for a bunch of horizontal applications and it's worked really, really well. Again, in a sense where these applications are kind of logic constrained and not data constrained. But with ML, as we talked about, that programming model becomes inverted because it's so data centric. And so what's really happening on the chip is you've got these super, super dense linear algebra operations. And often, we're dealing with gigantic models with millions of parameters. And the name of the game there is you want to really limit movement from, memory register to processor and back again. And so what these architectures really lend themselves to is actually a more of a data flow model where where you've got a ton of computing cores with high bandwidth memory right on the die. And so we've seen a huge resurgence in the number of chip companies because, the von Neumann architecture that we know, right, has been around since the 1940s, I want to say. Mm-hmm. And it's kind of dominated the computing landscape. But I think now because of the sort of inherent characteristics of, these data centric applications, we've got an opportunity to kind of, overthrow that, or not overthrow, but complement that with with a system that that's really well suited and is purpose built for data centric applications. So that's one, right? And we've seen a ton of activity in this area. We haven't placed any, we haven't made any investments in this area. I think and then you work your way up the stack. Right. I think there's a new framework that's come around, a new deep learning or ML framework that's coming online every week. I think people are continuing to innovate there, and I think that's fantastic. The more tooling, the more approachable it gets, the better. The more I think the faster we'll be able to innovate and make it more widespread. Another really interesting area that we've been paying attention to, and I don't think there's not really a company out there yet, but if you think about what Spark really did to unleash traditional big data and predictive analytics, Spark isn't necessarily the best suited processing framework or substrate for ML, just because it's really sort of hyper optimized for blocking, MapReduce workloads, and so it's not it's not necessarily the ideal sort of multi-dimensional data flow architecture that you're looking for. But there's really interesting research happening at UC Berkeley in the RISE lab and at Stanford's Dawn project that are thinking about these new computing and these new computing substrates for deep learning. And I think there's certainly an opportunity to build another Databricks or Cloudera that's optimized for the ML world.
Right. Let me ask you one last question, just to kind of for help folks get some perspective into how, especially early stage venture, thinks about timelines and so forth. So you talked about Datadog early on. We've always kind of followed this thing where there's a lot of cool companies out there, Datadog being one of them, that makes technology that's going to help applications that are in the cloud. And then every November comes along and we listen to the reInvent announcements and we go, I wonder if they're going to announce a service that sounds like such and such, right? Mm-hmm. And Datadog being one of those companies that's continue to innovate, stayed ahead of some native service that in Amazon. As you're thinking about this from an AI perspective, right? Software companies, how do you look at the time horizon to help to look at what your potential companies are, your portfolio companies, and say, like, how far ahead do they need to stay ahead of kind of the baseline of what an Amazon or a Google might bring in this type of space? Is that something that you consciously go through, or are you mostly saying, look, we want to get you going for the first 2 or 3 years or something? Is that a thought process that goes on?
It definitely is. And I think if you are competing along one of the kind of traditional 3 axes of technology, of better, faster, cheaper, mm-hmm. and you're on the application's critical path, you're going to be hosed. I think that when we think about new technologies or new companies specifically, right, technology is sort of table stakes, but the moment you start prioritizing that, to most end users or developers even, it's an implementation detail. And to me, you point to companies that have emerged over the last decade. What they're really good at is finding a way to build brand and resonate with their end users and build strong communities, and really think about them in terms of enabling real behavior change. And once you ingratiate yourself specifically to developers and show them what's possible, those brands and communities are really sticky. And coincidentally, it's what Amazon does really poorly, right? Mm-hmm. Like, they are, at the end of the day, sort of rote building block. And so, we've seen a bunch of companies emerge that, maybe do have a technological advantage over the 6 or 12 months, but then they use that technological advantage to drive. I don't want to say brand because it sounds so consumery, but to drive developers to their way of doing things. Yeah. Right. And so that's primarily what we look for. What new behaviors do you enable? What new applications do you allow me to build? How do I actually get stuck in your workflow? How do I become a tool that you use every day? Those companies stand the test of time, and I could rattle off dozens of those that have outcompeted or sort of outshined Amazon, despite Amazon having similar services. Right,
absolutely. No, and it makes a lot of sense. It's you always want to be not just a technology. You want to be something that they want to be associated with. They want to see continue to do better. You want them to feel like they're kind of tied into what you do. Your success is their success, and their success is your success. So
that's exactly right.
Makes a ton of sense. Real quick before you go, give us a couple of names of portfolio companies that that you're working with that people might want to go learn a little about, even if it's not in the AI ML space.
Yeah, well, I'd love to. I think part of the challenge of investing so early is that most of these companies haven't taken the covers off what they're doing. So, okay. There's a couple names I'd love to share with you. Maybe we could do this in a year where I could talk about them. A few companies that launched recently that are, I think most folks that listen to the show will be aware of. Obviously, we were the first investors in a company called Gremlin. Gremlin was founded by two guys who ran Amazon's and Netflix's chaos engineering team, and they're really the one company that's holding it's kind of holding the torch as far as making chaos engineering something as ubiquitous as integration testing. And so the thesis there is, as applications become components and you're relying more as componentized and you're relying more and more on third-party software, you've got this insane call graph and dependency chain where if one service goes down, your application's down. And so we saw this with Amazon's S3 outage and on and on and on. And so what these guys do is they give you a toolkit and kind of a framework for injecting failure into your production systems and watching services degrade or fail. And so in that way, Colton, the CEO, would say it's kind of like a vaccine where, you watch these things cascade, you watch these failure scenarios cascade through your system. And that way you can build stronger systems, you can build resilient systems. And, one of their great demos is, they've simulated the S3 outage from, what was it? I think last spring. Mm-hmm. And you can see how by building systems the right way, your application will be totally immune to an outage like that. So that's one. I think another exciting company is Replicated. So these guys provide you a toolkit to not only run your software on-prem for any sort of multi-tenant SaaS provider. They provide you with kind of a set of tools and a set of tools and libraries to allow you to deliver that offering to customers who prefer to have it on-prem, but also have a bunch of other libraries that allow you to do things like audit logging and access management and rolling updates and basically everything you need to run your software to basically deliver the same experience you would if you were running your application SaaS on-prem. And so we're seeing a bunch of companies actually in the dev tool space this is really resonating with. Very cool.
And and we had the Gremlin guys on episode 299. So if folks want to go back and listen and dig into that one a little bit more, if you check out show 299, we had Gremlin and Andrus was on and kind of early days, but very, very cool stuff around chaos engineering. Listen, Lenny, I know you're busy. I want to appreciate the time today and digging into stuff, folks. If you want to learn about Lenny's stealth companies, you might have to buy him a beer somewhere, catch him in San Francisco. But listen, we'll have to have you back on again. 6 months or so, kind of get an update on what's going on. We'll figure out if your premise is making progress. But it was great to finally have you on, and we appreciate the time today.
Yeah, thanks so much, Brian. This was fun, and always happy to come on.
Yep. Well, listen, for Aaron and for Lenny, folks, thanks for listening this week, and we will talk to you next week.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more podcasts, show notes, and everything social media. And visit acloud.guru for all your cloud training needs.